Welcome to week 9 of Introduction to Modern Application Development. In this week, we will start assembling all the pieces that we have learned up to last time and see where that takes us. We have been delayed this week because of the dramatic happenings of last week. There were some issues which we were dealing with here. So in the coming week, we will give sessions for both week 9 and week 10, and then have other things such as training material and so forth to get ready for the exam and how do you need to prepare. We will talk about that this week. Okay, so the plan, like it says here, is to put together all of these pieces, and we will begin with MySQL. Now, here is what you need to know about MySQL and databases in general. The first thing is that we will take a designer's perspective of databases, and all you need to really know, if you haven't used databases much before, is that a database is a collection of tables. In a sense, a table is no different from a file, with one distinction. Whereas a file is just a collection of bytes, a database is a collection of a database is analogous to a directory, and tables are analogous to files. And where files can contain just any odd byte that you want to put in, tables have structure. They are collections of records. So just like you can have files made of lines and lines made of words, something analogous goes on in a database. You can think of it as structures, as in C structs, or any kind of construct that you have learned, for example, classes in Java with attributes or member variables and their values, and collections of those which get stored in an easily accessible fashion. The only really odd thing about databases is the language that is used to access them, and unfortunately, we will only cover those parts of that language that we care about in this course. It's far too big a topic to address in any useful fashion. So what is odd about a query language is it is a way of operating on the entire set of records at the same time, rather than one record at a time. Now, updates often go to a single record, but retrievals are usually in bulk. There are some ideas behind how to design these tables and records that we will see. It's called Entity-Relationship Design. So the observation here is that many, how shall we put it, many information processing problems can be thought of as made of two kinds of things: entities, which roughly correspond to nouns, and relationships, which correspond to verbs in ordinary English. So in our example, entities are people, the persons who are made of, who make these groups, the group of friends, and the usual attribute that we care about is basically just the name. The second entity is their expenses, the amounts that they spend. And so an expense has two primary features that distinguish it, which is when did it happen and for what amount did it happen. What links those two is the action of spending, which basically says that a person is related to a particular expense because that person spends a certain amount of money on a certain date. So this relationship is not what is called relationship in a database. That is unfortunately one of those odd terminological things that you have to get over. Many times it is in fact the entities which are represented in the tables, and sometimes of course tables can also represent relationships. In our case, we will not need that. We will be able to synthesize the relationship we want as we need it. You will see what I mean in a little while. So let's see what thinking like this buys us. So what we have here is that our database will be called NPTEL, and we will have users who are the users of our application, and we will have expenses. These will be our tables. These users will have attributes. They will have an attribute, we are calling it user ID in both of these cases, and C time is the time at which a user was created, and E time is the time at which a expense was created. Uname is the name of the user, and amount is the amount at hand. So here we will change this to the actual type declaration that I use in the database, which happens to be decimal, because that is the usual way to represent money in this scheme. So that's how the database gets created, and we will see what it takes to actually do this. So by the way, this is what I mean by analogy between directories and files. So for example, the database is analogous to a directory, users for is a file, and expenses is a file. The contents of users are basically these three values, and the contents of the expenses table are these three values. So together with all these things, we will describe the structure of our data. And then once we do that, we can try out our queries, register new users, record an expense, and ask for a report the way we had planned. So let's see how to get to this. We have gone up to query design. Okay. So I will show you the details of how in MySQL this idea, this design that we have gets expressed. So first of all, let's go to this MySQL thing. By default, MySQL has just like we have a login as a user account, and inside that we have directories and we have files, and we can share it with other users. A similar structure exists inside a database, where a database can have certain users, and each user you can decide who can access which database, who can access which table, what can they do with the table, and so on. So by default, MySQL, which as usual I am using the MySQL in XAMPP, as I have done in the past examples as well. And here is what we have. So the default user is called root, and there's no password for that user by default. Of course, this is pretty dangerous, because in a real database you don't want that. The root is the all-powerful user, and you want a good password for that. But because this is just a demo, we will skip over the password, at least for the user. So there is no password, and therefore we just log in. Now, an interesting thing is, just as you have commands like ls and so forth to look at directories, similarly there are commands for looking at databases and tables. So here is databases, and as we see, there are some databases in here. Now I have already created this NPTEL database and another experimental database, so I'm just going to create NPTEL-3 during this recording. But I will follow the scheme that is shown here. These are the standard commands of SQL, which is the usual query language used to program databases. And you can pretty much do these things as shown in this set of commands here. So you can create, for example, NPTEL-3, and it says query is okay, and you can say show databases, and you will see NPTEL-3. These commands are used to create users. Now in this case, so for example, I will create user, I'm just going to say user N1, and have no password. Well, let me just do it completely anyway. So n1 at localhost identified by, which gives the password. Identified by, in this case we'll just use identified by p1. Now the question is, where did this creation of the user go? Interestingly, databases use the same command for their internal management information, the same kinds of commands that you use for user information. So in this case, you can do something like this. Things like user are created and stored in the database, which is itself called MySQL. So there's something slightly funky here. The command that we use is called MySQL. The database we actually installed in XAMPP is an open source version of MySQL, which was, I guess there's some Oracle bought it and some complicated licensing thing is going on. So the new open source version is called MariaDB. Nonetheless, you should just think of it as MySQL. So things like user, etc. are created inside a database which is itself called MySQL, and you can choose to, look at a particular database using this use command. And in a database, you can say show tables, and so it shows you a bunch of tables, of which one of the tables is user. Now, a table in turn is described by a schema, which is kind of like a class or a record or one of those kinds of definitions, which you can look at as by saying describe. So here what it says is, when you say describe user, it says it has these many fields, so quite a few fields. And the type of each field is given here, and there are a few other things here like can the field be null and so forth, and is there a default and so on. These things we will look into only those parts that we care about. So let's take a look at so what we want to show is host, user and password for the users that we have created. And the usual way to do that is to use a so-called select command. So host, user, password from user. User, remember, is the database of users. And if you want to be explicit, you can say mysql.user. Makes it a little easier to read without having to rely on this use command that we created earlier. So as you can see, after this select command, we have the users that are already there, plus the two that I have created here before, NPTEL user and NPTEL admin, and then the user N1, which we just created. In each case, this user is attached to a host. So this basically means that as far as this MySQL database is concerned, only from the local host can you actually talk to the database. Of course, normally databases sit by themselves on a separate machine, and so the machines that can be clients are explicitly declared, and usually on those machines what runs is the web servers themselves, which are part of the application that happens to use these databases. Here we have encrypted versions of the password, and we don't, in the commands themselves the password is in plain text, but in the database it is stored in this fashion. So in some of the more higher security cases where I have used these kinds of things before, the password is often actually shared in pieces between 2 or 3 different people, so that they all have to be there before the password becomes accessible. Now, this is needed only for things like the root password. For a particular application, you create a database such as the database NPTEL, and then you create multiple users. So here we distinguish between somebody who is just merely a user of the NPTEL database, whereas somebody who is a administrative user of the NPTEL database. And typically the administrator is somebody who you have to log in and set up the core structures of the database, whereas this kind of ordinary user can often be actually a servlet which contacts the database in order to deal with the content of the tables. So we'll see some examples of that in a little bit. Now, normally a user by default, when you create it, they can do anything at all. They are not as powerful as the root, but for these, but in general, a user by default in MySQL is unrestricted in many ways. What you can do is to narrow the amount of things that a user can do. So for example, if there was a mistake somewhere, you don't want the basic structure of the database to be corrupted. For example, from a servlet program which is contacting the database. However, the servlet has to be able to do a certain number of things. Distinguishing like this in a database is exactly the same as, for example, if you have an Android phone, etc. It asks permission to do explicit things like read your contacts or be able to read photos and so on. So similarly, there is a distinction to be made among what you can do to a table in a database like this. And the grant statement is used to do this. So in this case, we will do this for the NPTEL N1, and we can create another user called N2. Create user N2. And so by default, when you create a fresh user, that user cannot do much with MySQL. Let's start by creating some fresh users. So we will remove our existing users. By the way, by doing this, you can delete a user. And so if you take a look, now we are starting fresh. So let's do create user N1 at localhost, N1 at localhost, identified by P1, and similarly we have N2 at localhost, created identified by P2. And now if you take a look at what they can do, which you can do by now if you take a look at what they can do, which you can do by looking at show grants, then what you will find is something like this. So N1 at localhost, it will say grant usage, which basically means all you can do is look at the existing databases. And I think it also allows you to work with a special database called test, I believe. And it's the only database that a default user can use. By default, when you create a fresh user, that user cannot do much with MySQL. Let's start by creating some fresh users. So we will remove our existing users. By the way, by doing this, you can delete a user. And so if you take a look, now we are starting fresh. So let's do create user N1 at localhost, N1 at localhost, identified by P1, and similarly we have N2 at localhost created, identified by P2. And now if you take a look at what they can do, which you can do by now if you take a look at what they can do, which you can do by looking at show grants, then what you will find is something like this. So N1 at localhost, it will say grant usage, which basically means all you can do is look at the existing databases. And I think it also allows you to work with a special database called test, I believe. And it's the only database that a default user can use. Okay, so let's try this. We can certainly use test as this thing shows. Let's see if it allows us to use something like NPTEL-3. Well, seems like it does. What if we attempt to create a table in here? So let's create a field called F1 int, and let's let this be what is called the primary key. What happened? I just said that default users are not allowed to do any of this. Why is it that then we can create tables? So the answer is that unfortunately MySQL by default, the command line doesn't show you which user you are logged in as. And currently we are logged in as the user root, which is the reason why we can do everything. And to fix this problem, you can change the prompt like this. So this shows you the default database and also the current user. So that way it is much less likely that you will make the mistake of logging in as root. As usual, logging in as root, whether to your own computer or to MySQL, is generally a bad idea. You should log in as root and do whatever it is you want to do as root and immediately log out. But this is another way to protect yourself a little bit. So if you want to see the full effect, then let's look at our show grants for N1 at localhost. So here we have just usage, and to do this we will have to log in as the user N1. To do this, we first have to quit and then log in as MySQL U N1 and P1. And now if you try to do something like use NPTEL-3, then this tells us that access is denied for this database to this particular user. Okay, now let us go back to being root. Notice something else though. If we go back to the thing we were looking at, which is MySQL N1 and this password P1, then it seems like the command line thing no longer remembers the change of the prompt that we made. This change can be made permanent by putting it in various config files, etc. But for now we will use a simpler method of setting this change by using environment variable instead. On Unix, of course, the syntax is different, but basically the idea is that you need an environment variable like this. It's one way to get it to remember the command properly. So now let's see what happens if we do this. Okay, and now we have the current user and the current password, etc. is shown properly. All right, so let's get out of it and get back to being root. Right, so now it's root here. And now we can give grants to N1 and N2 and then see what happens. So first let's grant all on NPTEL-3 dot star to N2 at let's grant it to N1 at localhost. And so now if you do show grants for show grants for, then you can see that all privileges are available, and so it can do things like creating and deleting tables. So now we can say use NPTEL-3, and here you can create tables by this tables command, which we will discuss a little bit more in a while. But for now, just say that there is a field F1 which is a integer, and this it insists on having this guy as a create table there. So it now created a table, and so if you say show tables, it will show you that there is a table called XYZ in here, and if you ask to describe XYZ, it will say it has a field and this is an integer and so on and so forth. A field, an integer, and so forth. Okay, so that's the basic functionality of this grant function. And similarly, if you grant example select and insert on nptel.star to n1 at localhost, then again you can do show grants for n1 at localhost there. So we have I forgot, I was supposed to do that grant to n2 because n1 already has all privileges, and so it doesn't really matter much. So here we have this grant given to n2, and so now if we log in back as MySQL n2 p2, then you can use this database, but you will not be able to create a new table pqr which also contains this. So it says create command denied. But on the other hand, if you say select star from the table XYZ which we created previously, wait a minute, show tables, I'm in NPTEL, I should be in NPTEL-3. Looks like I made a mistake and instead gave the permission just for NPTEL itself. Well, never mind. You get the point that by using these users, etc., you can constrain what it is that a system can do. In any case, we don't particularly care about N1 and N2, so we will go ahead to our main thing, which is showing you how all this works. So this gets you the core idea of setting up databases. Now we have already seen some examples of creating tables, etc., but let's take a look at some more cases. So we have the basic fash setup, fash for fair share. And if we wanted to create tables, this is how you would do it. You have already seen me type a few create table commands, so I'm not going to type this long thing, but this is basically the two tables that we have in the database NPTEL. And if we say show tables, it will show you this. And if you say describe table users, it will show exactly what we have typed over here. So we are going to have a user ID. Big int, by the way, is 8 bytes, so 64 bits. And user ID is how many users can there be. There is a special thing in such a table called auto increment, which says that every time you insert a new user, a user ID will be automatically generated for it, which is one larger than the previous one. But in addition to that, we will also store the creation time. And in fact, it is the pair of creation time and user ID that describes a user. You can, because of this auto increment, use a user ID alone, but there are situations where auto increment may not be the right thing to do, and user IDs may come from a completely different data set and so on. But for now, auto increment and based user ID will suffice for us. Then we have a uname, which is 255 character username. Similarly, for expenses, what we have is the ID of the expense, the time when it was created, which user created it, and how much was the amount. And this description is available in this file over here. Okay, so now that we have our tables, we would like to populate these tables with something. And in this case, I have pre-populated these tables using these types of commands. So let's see what is in the table. You can see what is in a table typically by just doing select star. This is a problem if your table is very, very large, but otherwise for most practical purposes, this is good enough. So select star 1. Okay, so select star from users, and so this shows that there is a user ID is 1 and creation time some 1, 2, 3. I put an arbitrary number, and there is a user name and there is a user ID. So here the first column, when I do this insertion, is always 0. Despite that, the user ID is never 0. It is 1, 2, 3, 4 increasing. So let me just show you by creating another user, insert into users values. This, by the way, is SQL syntax, and I'm not going to explain that in this course. We just don't have time for all that. But I want to give you a sense of what it is like. So if you read online sources or pick it up yourself, the general picture is clear to you of what is happening. So here we have a user ID 3, which got automatically created, even though there was a 0 here. And similarly, I have put in some such thing into expenses. Now, of course, normally we ought to populate this from our web app, but this is just to get started. So let's do the same thing and create insert into expenses, some other creation time. And this time, by the way, we will need a user ID. So let's say we have a user ID 3 and the expense is some such number like 500.50. And so we have select star from expenses 500.50, which is okay because we have decimal 8,2 over here. So these are our expenses and users. But what is nice about databases in general is that you can do these kinds of complex queries. So the time we are storing here, by the way, is just an integer. This is the number we store here will be a Unix timestamp. So a Unix timestamp is the number of milliseconds from January 1970, which is an arbitrarily chosen starting point, but it's a very common starting point. And it's better to store a number which we understand ourselves and convert it into time. Now, databases have native examples of date and time and so forth. And expert database users can sometimes, prefer to have the database supported types rather than these external types. But there are advantages and disadvantages. We don't want to get into that debate. For now, we will just put Unix time and get on with it. And this is an example where you can do a query like this and get what we normally want is not just the expenses and the users. What we want, first of all, is the calculation that we are going to do, but that we will do in our web app. And before that, what we want is which user was responsible for which amount at which time, but with the name of the user rather than the ID of the user. And for that, what we can do is use this query here. There we go. So this is the query. So what this says is, take the expense creation time, convert it into a normal timestamp from Unix time, call it at time, take the username and the amount, and return all of these as a combination, what is called a join of users and expenses. And join meaning pick rows in which the user ID in the users table and the user ID in the expenses table is equal, and then for those rows get these kinds of pieces of information. And so the end result is that you get which were the users and how much will they spend, and this time we have the names of the users rather than their IDs. All right. So this is the primary purpose of a database, and what we will actually have to do in the app is to send queries like this from the server to this system and get the results. You have seen this once before. The difference between the previous discussion and this one is we explained a little bit about how it is that we choose to create the tables and how it is that we intend to use it for our specific application.